Hello and welcome. I'm John Watt. Have you ever wondered how our scientists are changing what we wear? This week, we meet a couple of Kiwi blokes who have gone from homemade technology to leading the world. And we look into the future of our very own super textile, wool. The noble New Zealand sheep used to be the engine of our economy, but across the world, wool has been losing ground to easy care fabrics like cotton and polyester. In order to compete, New Zealand needs to modernise. I'm off to find out about the cutting edge of textile design and manufacture. AUT's Textile and Design Lab gives New Zealand companies and designers access to all the latest equipment. Peter Heslop is the man in charge.
New Zealand isn't going to compete in the low-cost apparel market. Wage bills over here are far, far higher than what they are in China, Vietnam, Bangladesh and so on.
So Peter is looking towards high-end technology to find ways to give New Zealand manufacturers an edge.
The label will carry a lot of weight, we think, the Made in New Zealand label, but so too does the product itself. It needs to have that point of difference that will set it apart from lower cost imported goods.
One way to add that point of difference is in using the best in manufacturing. Gordon is the technician, and he's going to show us what his machines can do by knitting me a jumper. But first, he has to design it. So this is going to be my jumper?
Yep, we're going to make a jumper for you here today. So I'll just come in here.
So you can go here, you've got 66.5 body length, so you can get quite accurate measurements?
Yep, maybe within 1 centimetre, half centimetre, where you want it to be. Once you've got everything tuned on the machine, input the correct information in the CAD system, marry the two together, and you're there.
This is the forefront of software that automatically converts the design into something that the knitting machine can understand.
We're coming along. I think it's time for us to actually take this little program, put it in the machine and knit it.
So we're going to start it up?
Yep, we'll start it up and knit your whole garment.
All right, awesome. This is a whole garment knitting machine. So in goes the design and out comes the jumper. Is this a big leap forward in technology?
Yes, huge leap forward in technology. It's almost been the holy grail for knitwear for years.
The previous generation of knitting machines would knit the garment in pieces that would need to be assembled, increasing labour costs and waste material. This machine completes the whole process itself. So what are you showing me here, Peter?
What we've got here is our digital printing system.
We've brought our own cutting-edge design, which Peter is going to print for us. It looks like a giant office printer.
Yeah, good example there. That's pretty much what it is. If you think of the way that the ink or the dye is applied to the surface, it's actually sprayed on. It's non-contact, very, very flexible, versatile system.
With this machine, you can use as many colours or as complex a design as you like. Unlike conventional screen printing, which requires a template to be physically created and the colours are limited. That came out great. Can I wear it?
You can. We're just going to pop it through the dryer here, first of all, John, and you're welcome to slip it on afterwards.
The dryer fixes the ink, and then we have a finished jumper. Oh, it's nice and warm.
There you go. Great for a winter's morning.
Oh, fits beautifully. I'm leaving Auckland now, but the jumper's coming with me. Down to Ag Research in Lincoln, where it's going to help me find out why textile scientists are combining wool with a material used in spacesuits. Stuart Colley thinks wool can protect us from serious injuries.
We're developing a wool fabric that has a good protection level against stab resistance, cut resistance and fire, but looks and feels like a conventional fabric that you could wear every day. We're harnessing the natural flame resistance of wool and combining that with the properties of a synthetic fibre called Vectran.
The flame-resistant properties of wool have always been known, but Vectran is the new generation of fibres. This is extremely strong and is used in high-performance applications from spacecraft to bicycle tyres.
If you made a whole top out of Vectran on its own, it would probably be a little bit like wearing some kind of chain mail. Well, this is a garment that's been made from the fabric, so you can see that it feels quite normal, sort of lightweight.
It is quite nice and soft, eh? Yeah. Just looks like a standard bush shirt. So what about the flame-resistant properties?
Yeah, we can show you that. If we get you to hold this piece of fabric here, it's the same type of fabric as we have there. And if you grab a hold of that one there and just bring it onto the fabric,
right,
and start burning away and see what you feel.
Feels nothing yet. Just looks cool. Smells like lamb's tails. Wool is a protein fibre and doesn't burn well. In fact, as it burns, it creates a charred coating that actually prevents further burning. Adding the Vectran provides a strong fireproof structure that holds the charred wool in place.
So you get a really good sort of synergistic effect of the two fibres together.
How much wool is in here?
It's about 70% wool and 30% Vectran in that one.
There's a lot of wool.
That's right, yeah. So and we're really just reinforcing the wool properties by adding the Vectran to it.
I'm kind of getting bored of the fire. It's going for ages, so what about stabbing?
Yeah, let's have a look at that.
Yeah, that sounds fun.
The Vectran gives the fabric really good cut resistance. So if we demonstrate what that means.
The material is not stab and flame proof, but it does provide a lot more protection than standard fabrics.
The product doesn't meet the standards that are required for people who are currently wearing protective body armour, such as the police or military. The target markets for the product are people for whom a slightly lower level of protection is needed. So that could mean that it's useful for people like security guards, for ambulance officers, and with this type of fabric they can have a level of protection without compromising their ability to otherwise do their job.
So now we're going to do a little stabbing test on the jersey that we had, mate?
Yeah, let's do that.
We're going to raise the stakes and do a test on whether or not Stuart's material can protect our ever-wondered jersey from an attack. So what am I going to stab him with?
Well, I think we'll stab him with a screwdriver, because we're talking about this fabric being used in scenarios where an improvised weapon might be used against the person.
Right, so I'll lie him down. Can I go full force?
Yeah, see how you go, yeah.
Maybe I'll start soft and see how we go. Didn't even make a mark.
No, nothing at all.
Maybe two hands. Nothing at all.
Yeah, I mean, eventually there could come a point where you could get through, because we'd never say something is stab-proof, but
right.
So we're always providing a level of protection. And against something like that, you know, it's providing a good level of protection.
So you're still going to feel the force, but you're not going to get penetration, so there'll be no penetration.
That's right. So you're probably still going to get some bruising, maybe cracked ribs or something like that.
Right.
It's not going to be pleasant, but
Yeah.
hopefully you're still going to be alive afterward.
Right, so let's whip this off and we'll see how the jumper went.
Yeah.
Right near the heart I went for, and there's nothing. That'll just sound malicious. High-quality New Zealand wool is no stranger to the catwalk, but Vic Uni have found a new way to give it something extra. I've come to meet some scientists who are using cutting-edge nanotechnology techniques to colour wool with gold and turn it purple. Jim Johnston is leading the research.
We combine the high value of wool with a high value of gold for the top-end markets, where people are very discerning and they want something that is actually different and something that's high quality.
Jim is combining wool with nanoparticles of gold. These are absolutely tiny. To put it in perspective, comparing the size of a nanoparticle to a basketball is like comparing a basketball to the Earth. When gold gets this small, the colour actually changes.
When you look at metallic gold, everybody's familiar with the yellow luster colour. Now, when you make the particles smaller, down to the nano-sized dimension, then you get an effect called surface plasmon resonance.
When light hits a lump of gold, the particular wavelength that is reflected back is what we perceive as the colour gold. But a nanoparticle of gold has a very different surface, which changes how light is reflected, altering the wavelength and thus the colour that we see.
And therefore, by controlling the particle size of the gold, we can control the colour.
Now we're going to head to the lab, where Kirsten has kindly offered to show us how to turn gold purple. So Kirsten, how are we going to make purple gold?
Well, we're going to take some gold metal, which is nice and shiny
Very shiny.
and quite heavy, and dissolve it in a strong acid to get gold, individual gold atoms in here.
So this has single gold atoms in it?
Yep, individual gold atoms.
Cool.
So what I've done, I've just got some water heating up here, and I'm going to add some single gold atoms to the water. It's going to stir around, and then we're going to add trisodium citrate.
This trisodium citrate allows the single atoms of gold to combine back together as pure gold, but limits the growth to the nanoscale.
By varying the ratio between the gold atoms and the trisodium citrate, yeah, you can control the size and the shape of the gold nanoparticles.
And what does that mean for the colour?
That changes the colour. So here we go, we've got some purple
Cool.
gold nanoparticles.
Can I pull that out now?
Yeah, for sure.
Purple. Purple gold.
Yeah, purple gold. So,
But this is gold though. I mean, this is this, but at a different length
yeah,
scale.
yeah, exactly. The gold is the same, has the same chemical composition, just the size is different. And if we change the shape, you can get different colours again.
So what are
here, these are gold nanorods,
Right, and these are spheres?
and those are spheres, you're right.
So just by changing the shape, you change the colour?
Yep, pretty cool, hey?
Yeah.
This is a big hank of wool that we've coloured with the gold. And obviously it's really valuable because this is only wool and gold.
Nano gold wool would be one of the most expensive textiles on the planet. It takes about $500 worth of gold to dye 1 kilogram of wool.
These are samples that we've also coloured with gold. So we put the nanoparticles on the wool and get all these colours. But I can't tell you how we do it.
Why not?
It's a big secret.
Sounds brilliant. But they won't show us how it's done. Secret squirrel.
We've developed a completely proprietary technology which enables us to form the nanomaterials actually on and within the wool fibre and actually chemically bind them to it, all in a single step.
That makes the chemical bond extremely strong, so it has stood up well to colour fastness testing. And because the pigment is made of pure gold, it also makes it resistant to the sun. These qualities are particularly useful in products where durability is a big advantage.
The major markets are those top-end carpet manufacturers for luxury residences, luxury yachts, private aircraft, palaces, that type of thing.
Gold has antibacterial qualities, which also has big benefits.
Nano gold wool shows remarkable resistance to moths, and that's a major problem in carpets where you have to add insecticides to actually combat the moths. And so with the gold wool, not only do we get the quality aspects, the fashion, the association with the gold and the fibre, we get all these other benefits as well.
Another possible market is in the area of high fashion. So Jim has come up with a competition to help realise his material's potential. The guys at Vic Uni have come up with the science. Now they're looking to Massey University's School of Design to add a little bit of art. Kelly and Brita, what have we got here?
We're designing for the Nano Gold competition.
And what's the competition for?
Well, basically, we're just creating designs that could be used for promotional use for the Nano Gold fabric.
The winner will work with Victoria University to make their design and also head to an international textiles conference in Italy.
This one is actually mixed with some lycra.
So is it stretchy?
It's stretchy, yeah, and it's slightly felted, so it's really quite soft to the touch.
How come it's not purple?
We can't get our hands on the actual fibre, like I'd love to work with it, but hopefully if
Too
we will.
expensive?
Yeah, it's too expensive.
Too precious.
Too precious.
Yeah. And what have you designed, Britta?
Well, merino wool and gold are associated with wealth and high fashion, so I was looking at excess and greed and gluttony and the idea of too much.
And what excites you about working with the nano gold?
I like the science part of it. I was into chem at school, and so it's just great to see the two things coming together for once. The forefront of technology, be part of something brand new.
The people who have got these products can say, well, it's only pure New Zealand wool and pure gold. There's nothing else in it.
We've looked at some of wool's amazing properties, but unfortunately, it has one huge problem. If you machine wash or tumble dry it, it shrinks. It may seem like a simple puzzle to solve, but finding an environmentally friendly way to make wool shrink-proof has confounded scientists until now. After years of trials, Surinder Tandon at Ag Research in Lincoln finally made it possible.
The hardest thing was when the fabrics from the initial trials kept on shrinking. So it was quite challenging, and I believed that we could solve this problem. Yeah, and we did eventually, yeah.
The problem with wool is that it is a rough fibre, and when you add water, heat and movement, the rough edges mesh together, getting tighter and tighter, shortening the fabrics and shrinking your jumper. Surinder's shrink-proofing innovations were purely in the mechanical processing of wool, unlike previous methods which used harsh chemicals such as chlorine.
We spin this wool into a yarn which has special structure in which the fibers are well interlocked and the yarn is not hairy.
Surinder takes the normal hairy strand of wool and splits it into lots of substrands. These are then twisted back together, binding the rough bits inside the yarn, making it incredibly smooth and fine. This is all achieved by adding a cheap and simple modification to current spinning machines. The next step is weaving the material.
We are able to pack a large number of threads in the cloth, so when we wash this fabric, the yarns cannot move, so the fabric cannot shrink.
These properties have inspired the country's top designers to revisit wool as a material, even stealing the show at Fashion Week.
It's very satisfying to see the new fabric developments coming on the catwalk. You know, it's a biggest satisfaction for textile technologists when technology goes commercial.
Surinder's technology has also been taken up by large commercial manufacturers such as Cheo Samsung in Korea, Burlington in the US, and Nanshan in China.
The most satisfying moment was when the general manager of a Chinese company held the fabric in his mill and said, "Excellent product."
Surinder's innovation has made wool more resilient and may have a big effect on New Zealand exports. But up in Palmerston North, there's a company that's also driving exports by taking the resilience of what we wear to a whole new level. I'm off to meet a couple of Kiwi blokes who have spent years developing their very own unique technology to become world leaders in a very niche market. Simon is the business brain behind Oboe's technological innovations.
We decided in 1992 that we would focus on the goalkeeper for field hockey and just went for it.
There are only about 100,000 hockey goalies in the world, but Simon saw that they were a neglected market.
Our market share globally is in excess of 65%, and we sell into 61 countries at the moment. I think the one key factor to our success has been focus, that we've decided to do one thing and do it incredibly well and better than anybody else in the world. So for us, research and development has been a key part of what we've been doing from the beginning.
Oboe built a laboratory so their testing could become more sophisticated and turn their focus towards becoming the best in the world at protecting the human face from injury from balls. The technical mastermind behind this revolution is Ruben.
First project that the lab was built for was the development of this new face-off mask. The guy underneath here is Noddy. Noddy spent most of last year sitting in front of the cannon having softballs fired at him.
Ruben built a cannon for the testing, and the first thing they did was see how competitors' masks fared. As this high-speed video shows, there was plenty of room for improvement.
What I did in the end was I made a polystyrene head and hollowed it out so that I could demonstrate just how far it was going to go concave into your skull if your nose wasn't there to stop the ball.
The result of this research was the face-off mask. But at the moment, Ruben is in the early stages of a whole new kind of testing.
We've just started work on a project for a martial arts equipment manufacturer, developing a new chest guard, which they use for sparring. And so we've reconfigured the cannon so that instead of firing balls, I'm trying to mimic a human punch.
These punch-mimicking missiles are being fired at a pendulum, which feeds the information about the strength of the impact into Ruben's computer.
What we've got in the cage here is the pendulum that we fire the missile at. The foam that we're testing will be put on the front of the pendulum.
Right. So the pendulum's almost acting like the body of the athlete.
Yeah, it's acting like your chest.
Can we fire something at it?
Yep.
The cannon is powered by compressed air, and Ruben has managed to fire objects at up to 300 kilometres per hour.
Is it loud? You might pay to cover your ears, it's fairly loud. You ready?
Brutalised. Ruben measures and records each impact and is now ready to start testing how well different padding materials absorb them. Looks like you got a lot of samples to get through.
Yep.
And a lot of combinations of samples.
A lot of work ahead of me.
While Ruben works away, the manufacturing process is running night and day to keep up with global demand for their gear. Every machine has been custom designed and built to give the level of performance Ruben's rigorous testing requires.
We also do a lot of testing on the field to make sure that we've got it right.
Yeah, and you sell these in New Zealand?
These are sold all over the world. This is about a $700 item.
$700 for a pair? Or?
For a pair. Well, we sell them as each, but you get one free. So.
Right. So, can I try them on?
Sure, go for it.
And this is the right?
Right leg.
Yeah. No, it's comfortable.
Comfortable. Still, go for it.
Do they work?
Have a go, Jimmy. Show John if they work or not. Harder.
Try again. Maybe that's enough. Didn't feel a thing.
On one or two occasions now, I've sat in the stand at a world event, Olympics or a World Cup of hockey. I've just looked at both ends of this pitch, everyone there, the goalie's wearing our equipment, and I've thought, wow, that's really cool that we, as a small bunch of New Zealanders, have done that.
New Zealand researchers are adding outstanding ideas and innovations to one of the oldest industries we have. They are increasingly shaping what we wear, going beyond fashion by adding function. See you next time.